See my screen? No.
Yes.
Okay. All right. Hi, everyone. My name is Ijeoma Eti, and uh, okay, a second. Okay. Hi, everyone. My name is Ijeoma Eti, and I'm a software engineer. Today, I'll be talking about service mesh in Kubernetes, how it works, and why it matters. Um, So just a little disclaimer before I start talking. Initially wanted to do a live demo for this talk, but I think the talk is quite broad and I would just stick on the theoretical aspect of this talk. And maybe later in the future we can have a demo on it. So about me, I'm a software engineer and I'm really passionate about sharing knowledge through technical writing. I'm an active contributor in the community. I currently maintain Layer 5 Meshery project. Yeah, and you can find me on my socials below. Oh, sorry. Okay, so this what I'll be talking about. I'll be talking about the um, I'll start off by talking about why we actually need what's brought about the need for service mesh. So I'm going to go about from microservices to Kubernetes and then service mesh. So yeah, it's going to be a very interesting one. Okay. Yeah. So the microservice shift and Kubernetes growth. So let's start by looking at how like we exactly got here. Um, Before, let me say in the past, like several years ago, um, applications were usually monolith, meaning that they were built on they were just built on one they were all built together, like they were tightly built together, all your unit of your application. So from your if you have an application, for example, an e-commerce application, the payment, the authentication, and everything were all built together as a monolith and deployed together, right? And one of the drawbacks was that when this applications begins to scale, we the developers or the engineers found it hard to would like have to scale the entire applications together, right? So even if, like, for example, it's just the payment part of the application that is having a lot of requests, right? We would need to scale the entire application. So one thing that was like a really drawback because we needed a way to see how we can just scale one single application if we need to give that part like enough resource. So to solve this issue, basically the industry shifted to using microservices. So instead of like building one big application, one thing the industry tried to do was we could build application into smaller independent services. So each service can scale on its own. So you can, if we're having a lot of like requests on a particular service, we can just scale that service instead of scaling the entire application. And that way, like developers could just make releases really fast and you don't have to wait for the entire application to be scaled. So yeah, so I just highlighted some of the advantages of microservice here. So one of the things is scalability. With microservice, you can easily just scale what you want. Like I said, then you can deploy really fast and release to production really really fast. And then different things can work on different services. So why do we need Kubernetes for microservices? This is where it gets very interesting. So now microservices sounds like really, really great, but running them right efficiently it's like it introduces another challenge, and this is where Kubernetes really come in. So Kubernetes basically is designed to run and manage containers, right? It's an orchestrator designed to run and manage containers and to make sure that you can easily start, stop, or scale your services automatically when needed. Kubernetes it was also designed to like manage It was also designed to help microservices communicate with themselves properly. It means that like you can one service you can easily Kubernetes helps a service, for example, the payment service to easily communicate with let me say the authentication service in your microservice and all. And now with Kubernetes, scaling your microservice became like much more easier. You can automatically add or remove instances based on demand, like I said earlier. And then you can ensure that like the application is running smoothly. So if anything happens, Kubernetes can help restart that service and then also distribute the workload across like all the services. So another thing advantage of like Kubernetes in microservices that um, it just ensure that teams can now like focus on the main, like for example, if you have like a very wide big application, right? So teams can focus on the main or the applications that are probably are like taking a lot of resource and sort of know how to automate and manage those services. So Kubernetes just brings in consistency and ensures that you can run Kubernetes on cloud, you can run it like on premise, and you can have like an hybrid of both of them. So the next thing here is the microservice building block. So I'm just trying to go over all of these things before I go to the main service mesh, because like this will give us a bit of understanding of why we actually need this service mesh in Kubernetes. So the building block of Kubernetes microservices consist of different essential components. So this essential components basically helps Kubernetes to run smoothly, right? And then we have, from what we have here, we have the configuration service, we have the configuration service. So basically, what it helps is like it just helps to configure the major things, like for example your database connection or external APIs. We also have like the event driven messaging. So um, most microservices that I know about do not like just make direct calls to each other. So most times they communicate over like asynchronous messagings, like to just help decouple this um, microservice. We also have things like, I won't just go over everything. So I will have things like monitoring. So in your microservices, like I think some of this hotel thing that Ermosele talked about, you can use them like you can a microservice. When you're building your microservices, you want to implement things like monitoring to track metrics like responses or what happened, or maybe for example if your microservice fails, you want to know, okay, what's the cause of the failure. And then there are things like retry mechanisms. They're just like a whole lot of building blocks. Like I wrote here, we have the API gateway and the audits, which I may not go deep into all of them now. So now the next thing is the challenges that arose with Kubernetes and microservices. So the one thing about different tools is that when you introduce one tool that solves a problem, it brings in another problem. That's the way I like to see it. So yes, Kubernetes and microservices worked like really well, but when your microservice begins to grow really large, like you have, for example, there are companies that have close to 200, 300 microservices, right? So when it begins to grow really large, and then there are issues that arises, like issues in terms of communication. So communication, that's for the service to service communication. So when you have fewer services, managing these communications are really, really easy, right? But when they grow really large, it's very difficult to manage like routing. So for example, if you don't manage your routing well, it can lead to like a very high latency. And when someone makes request to your website, it's the response time is really, really slow. And then also another issue is like if you want to maintain like a service discovery of very large services can like be challenging. Then another issue that this this brought about is the fact that security can get really, really complicated, right? So you can, like, every service needs proper authentication because these services are deployed like, yeah, look, I want you to like think of them as separate applications, sort of like separate bit of applications running on their own. And then you need to sort of secure each service. So a hacker or someone can just go in, like, make a request or do something to your service. So security like became managing security when you have large services. It became a problem. And like, for example, you now run into the risk of like vulnerability or like inconsistency across the system. Then another notable problem I could talk about here is like service failure can the main of the one of the things microservices was trying to solve is that we don't have a single point of failure. So, for example, one of your app fails, right? It shouldn't affect every other app. Like in terms of monolith, if one part is broken or failed, like your one part of your system isn't working, everything is not working. But when we have like really, really large services, this can occur in microservice, right? So if one service goes down, it can impact other independent services, especially when we have like a really large service, right? I think this is called like the cascading failure. So ideally, circuit breakers or retries can help to manage this, right? Manage most of all these problems. But the issue is that we can't keep implementing this on every service, which I will go over that like in other slides. So I just wrote like our desired state of microservice. We want to build a microservice and we want the developers to just focus on the business logic and not to bother about the networking concern. And we also want like communication between the services to be automatic. So we don't want to, like I said earlier, we don't want to set up. So you have, let's say we have 4 services, or ideally it should be lots more services, but let's say we have 4 more services. We don't want to like focus on writing or using a library for service A that manages the communications and the security and every other thing, right? Or the retries and circuit breaking. Like we don't want to have libraries for each of these services because configuring these libraries can be complex. And then another thing is that it can take time, the time that developers will use to focus on writing out the business logic and solving the business problem. So that's our desired state for a microservice. And that takes us to the next slide. So like I said, we need to have like, from what I discussed about like the previous slide, we want to have a way that the developers take out their minds from all these things and then just focus on building this. So in the cloud native space, right, there are different companies that have built out solutions for this thing, and that's what we call the service mesh, which brings me to the meat of our talk today. So, what's a service mesh? It's basically just like I said, there is a tool, or it's just like a dedicated infrastructure that sort of helps microservices to communicate smoothly and securely, right? So instead of each microservice to handle things like traffic control, load balancing, and every other thing, like this service mesh handles everything for you. And right, so you do not have to implement all these things here. You just have to use this third-party tools that companies have built and then put it into your system, like use it in your microservice and it works. So I just think of it like something like an invisible layer, right, that just sits between your service, or like it just sits between your service. And then when you make a request, to a service, like you probably make a request to service A, right? That request goes to the it first of all hits the service mesh, and then that manages the whole communication. So so the next slide. Okay, yeah. So this is how the service mesh design, and basically, I think for years, service mesh has been designed using just the sidecar proxy, right? And I would explain that now. So, what are like sidecar proxy? Like, I would like to look at it as it's like a dedicated proxy running alongside each service, right? So, like I explained earlier, when all the network traffics, your requests coming in and those that are coming out flows through this proxy before actually hitting this service. And this proxy takes care of things like security, it takes care of like your routing, monitoring, because most of these services actually implement tools to handle all of this for you. So you basically do not have to write this in every of your service. And then the yeah, sorry. So that's for the sidecar part, right? And then we have the sidecarless part. This is a relatively new design or new thing that came to Seven Mesh. New in the sense that I think it came like 2 to 3 years ago. And then I haven't really used it well enough, but I just read it. I think I read it in the Istio documentation. I think some other people must have implemented it, but Istio have this thing called I think it's ambient mesh. So basically, the site calculus, right, is like instead of attaching proxies like to each of your service, what is does that the network layer is sort of integrated directly into like the your main infrastructure. And most times they use tools like the eBPF to manage this. So what like the site calculus helps to do is that it reduces like the overhead. So running a proxy in each service mesh, in each microservice has like a problem, which may not be a whole lot. So Sitecalers was basically was implemented sort of to solve the problem for adding a proxy, and it sort of improves like your performance of the service mesh. So this, like I said, this is relatively new, and many companies that you might get to work in might not implement this yet. Um, yeah, so the core components of service mesh are we have the data plane. We have the data plane. And what the data plane basically does is that it helps to handle the traffic, right, between services. So using things like sidecars, like I said earlier, I was trying to explain that we should like think of sidecars like something that just sits in each of your microservices, right? And what this data plane does is that it helps to manage things like your load balancing, your routing, and also observability, right? This is the component that is responsible for that. And then we also have the control plane, right, which is the brain box of the service mesh, right? This is where like all your policies are being for your traffic are being defined for security and for monitoring. Like every policy is being defined there, and it helps like it distribute these rules to different data plane in your microservices. So so yeah, we have examples of these are like this is my personal opinion, right? But these are like from what I've seen a lot of people use. These are the most popular service mesh. We have the Istio, we have the console, and we also have the Linkerd. So all of these things like Istio from my research, Istio is like has a lot of features, right? And then it offers like really advanced way of managing traffic and security. And then if you want something more lightweight, I would say that you go with the console, right? It's a very simple thing. You can probably just start with that. And then we have the Linked. Linked works very much like Istio. I also feel like it has a lot of features, and then it's also lightweight too. So this, like I said, this is my personal opinion, and then I think if you try out like these services, you can make your choice depending on your specific needs. Um, so if you remember earlier when I talked about the challenges that comes with managing microservices, I said things like you have to for each. So this is for this image here. It's like three different microservices, right, in the Kubernetes cluster. So I wrote Go here, but it could be like Python, it could be any gram. I feel it could be Python, it could be like any language here, right? So we can see here that this is a service A, this is a service B, this is a service C. I see that all of them implemented like the service discovery, like we had to install libraries to implement all of these things and then manage these libraries. And this can bring in like inconsistency across like different services. So for example, imagine library A, right, is using like a version one of, imagine service A is using a version one of the library, and then um um the service B, that's this one, the service B is using like a version 2 of the library. So we can have the whole library compatibility issues. And then I think another thing too, we can see the networking part here. Developers have to focus on like managing the networking and writing the networking part of this each microservice, which can take a lot of unnecessary time and also adding more complexity or slow down like the development. So what we want, like I said earlier, is just a way to remove all these complexities from microservices, so just developers can focus on delivering the business need. So we have the Kubernetes. This now is a Kubernetes cluster. We're running the microservices, and we can see that this is a service A, this is a service B, this is a service C. And now we do not have all of those traffic routing, retries, and everything. We just injected. Um, um, what we did is that we are using service mesh here. And how this works is that service when we install a service mesh, so for example service mesh like Istio, right, it's we can inject these sidecar proxies into these microservices. So we can inject into like the first one, second one, and third one, on like number of microservices you have. And then instead of each microservice sort of handling all those whole things, the sidecar will just handle it for you. So like when service A wants to communicate to service B, it doesn't talk to like service B directly. It should just go through the sidecar proxy, and that will manage everything, including the routing, including like the traffic policies and every other thing. And this works for like communication across like all the other microservices. So if we can see here, we have a control plane sitting on top the microservices. Like I said earlier, what it does is just it manages, control plane is what is responsible for managing these proxies like centrally and ensuring that like the policies are consistent. So like the previous image I showed, like we saw that we could have different versions of this library, and in different versions there might be features that are not there and all of that. But basically what this control plane ensures is that every sidecar proxy that's like installed in the microservice are the same and they're sort of consistent. um okay, so I was supposed to do a demo here, but it's going to be quite not really complex because I need to explain like a whole lot of things, and then I saw that it's going to take probably an extra 20 minutes or to 30 minutes. And for this talk today, I won't give a demo. Maybe in the future I will talk about that. So like I said earlier, you do not want to. One thing about technologies or tools is that you don't just want to use any tool because like you hear of like just a tool comes out and then you want to jump into it. So there's use cases for using service mesh. Like I explained earlier, if you have a microservice just handling two services, or just maybe less than 10 to 20 services, you do not need to actually use service mesh, right? Because the communication can be a bit simpler, right, to manage. It gets really complex when you have a lot of services, right? And then also, if you want to just do like a basic, if you want to, you don't need any very complex traffic control in your services and all of that. You can basically just use the basic load balancing. I think Kubernetes provides that already. And then if you don't need to like do any deep logins, like to see very core details of all your services, like if these are not your major thing, I think you can do without service mesh. And also I wrote here, like if you like your application is not having a lot of traffic, right? You're not having like millions or hundreds of thousands of traffic. I do not really think like you might need to use service mesh, because like I said earlier, introducing every tool comes with its complexity, even though it solves a problem. So so in conclusion, like I said, service meshes sticks out like the hassle of you managing your microservice in Kubernetes. And then they help you just manage things like communications, your security and observability of service. Do not use it when you're just having two service or three service. Yeah. Thank you.
That was an interesting and also really explanatory topic. I think now I know exactly why we need service meshes, because I always used to ask so many questions. Like, I mean, we can do without service meshes, right? Because whenever I'm building a basic app, I always just say load balancing will do the job. And now I'm seeing a clearer picture of why and then when it's very essential. Thank you so much for that, Ijoma. And if there are any questions so far for Ijoma, please drop it in the chat. But I think I have one question. And maybe I think this question is coming from the fact that I always like mix service meshes and like other things that help with managing communication. For instance, I always mix up service meshes and API gateways. I'm like, if we have service meshes, why do we still have API gateways? And why can't we use API gateways to like do the work that service meshes do? So can you just give like a brief differentiation between these two?
Oh,
You're
sorry.
muted.
I'm muted. All right. So I used to also have this thing too. Like I think it's a really, really valid question. It's a very good question. So API gateways and service mesh are, they both do the same thing but sort of different thing, or like they do the same thing in terms of managing communications, but like their purpose is like quite different. So I see API gateways as like a way, um I hope I'm using the right word here, but it's like more like a reverse proxy from requests coming from like coming outside your backend, right? Like some requests coming from the browser to your applications, right? So API gateway basically helps manage like that requests, right? So it's like managing requests coming from the external, like the browser or something, down to your services. Then service mesh sort of manages like it's I think they call it like an east-west traffic, right? So it manages communication within your services, not from not
Um,
from external request, right? So that's the thing. It's like managing your service communications. This other one is managing communication um coming into your backend.
okay.
That's
Okay,
just a
that
sub.
makes
I think there are more things to it, but I think that should do. That's the way I understood it, and then there are other components that, well, yeah.
thank you for that. Are there any other questions for Ijoma? Okay. All right. So, Ijeoma, thank you so much for that very insightful presentation. I enjoyed every second of it, because it was just answering the questions that I've had all the while about service meshes. Can anyone hear me?
Yeah, I can hear you.
Okay.
Yeah, I
All
can hear
right.
you.
Okay, so thank you so much for that. That answered like most of the questions I had regarding service meshes, and it was great to really get more insight, more insight into what service meshes are on like an in-depth and also like a broader level, because now I'm not going to be mixing up load balancers, service meshes, and then API gateways, because these are like three things I always mixed up. I'm like, why do we have different things that do the same thing? Just managing communication, right? And thank you so much for that. This was a very insightful session. I think if there are no questions for Ijeoma, you can always connect with Ijeoma much later. And she also is contributing to an exciting open source community that you can check out, because I've been part of the community. So yes, I'm being biased, but yes, you can check out the community after now. They do a lot of work in letting you know more about like service meshes and the likes. So if there are no more questions for today, that would be all for this month's meetup. And I really enjoyed every single topic. I hope we all did too. And I'm happy we all stuck around to see the end of it. So, that being said, it's always great to join here and learn from every single person that is bringing their insight into this. And to wrap up, I would also like to reiterate that our next month, I would like to have like us to have more of an open panel discussion where we bring in inputs on topics that we want to hear from other people, from want to get their opinions on a broader scale, right? So if you have a topic of interest that you've had questions, like for me, I have a lot of questions in terms of like the whole AI and then cloud thing. I know someone mentioned they wanted to learn about like platform engineering and why it's becoming a thing. Yes, Theophilus, here, your hand is raised.
Yes, sorry, good afternoon, guys. Sorry, I've been listening in the background and I actually just wanted to chip this in, right? For those that really want to learn Kubernetes and you you don't have the platform to, or probably you have the platform to, but you really want to know this thing in depthly. Sorry, I just wanted to chip this in. Um, you could use, there are a lot of open source frameworks out there like Killer Coda that can give you up to like 1 hour consistently of spinning up Kubernetes clusters, and you're just trying out your thing, whatever it is you want to do. Like I learning about Kubernetes, that was the approach I took, right? Whatever I learned, I used Killer Coda to get hands on. And again, when you get to Killer Coda, you see that there are a lot of scenarios, whatever it is you want to learn, networking, like understanding service mesh. If you don't know Kubernetes networking in depthly, it will be almost like teaching somebody who is in JSS1 further mathematics, right? So you might have to, in fact, learning about Linux, you have a Linux playground there where you can try out everything you want to try out. There are a lot of free frameworks out there, especially if you don't have the money to pay for certain things. I mean, there are free things you can use to move along. Yeah, I just want to chip that in. Thank you.
Thank you for that addition. Oluwafemi, your hands are raised.
Yes, hello everyone. I just wanted to like follow up on the resources for labs. So based on what Ijeoma talked about, which is service mesh, one of the interesting resource you can learn on like hands-on lab is Cilium. They have very, very, very interesting and very comprehensive lab in regards to different type of features when it comes to service mesh and everything networking in regards to Kubernetes, API gateway, and the likes. So that's a very good resource to learn from.
Thank you. And I'm
You mentioned
just
a
hearing
minute.
about,
So
yes,
sorry. The last guy that
Femi.
spoke.
Okay, Oluwafemi, I think we're trying to get more context into the name and the link of what you just shared.
Yes, it's Cilium. It's one of the I won't call it a service mesh because they provide more than that. They provide different solutions across service mesh, API gateway, EVPF solutions. So they are let's say essentially a networking solution when it comes to Kubernetes and also like infrastructure networking. So they have labs, different labs, very comprehensive labs across a lot of solutions in regards to networking when it comes to Kubernetes. So that's the link there, which is cilium.io/labs. So you can use that for anyone who's interested in going more into like service mesh and like anything networking in Kubernetes. That's it.
Awesome. Thank you all so much for these resources. And so, if you are trying to get into the Kubernetes or you're just new to it, but you said, let me test the waters, we're most likely going to be getting more resources like this, right? Because a lot of times we have experts join here just to drop their 2 cents. And you can also reach out to this person to ask for like additional inputs after now. So always feel free to jump in, and you can also join our WhatsApp group to ask more questions. Although for now it's very very inactive because there's just not much going there. We can always ask questions on where do I get resources? I want to learn. Where do I get free trainings and all of this? We're always ready to share whenever the opportunity comes up. So thank you all for sharing that. And that being said, remember to follow up as a member so you get notified when we announce the open panel for next month. And if you also want or have a particular topic of interest you'd like us to bring up on that day, do well to send us a message as well so we can include it into the pipeline of all the amazing topics we want to discuss in our open discussion. So that being said, I'd like to give you all your time back. Thank you so much for joining today and this month's webinar, and I look forward to seeing you in the coming months. Have a great day, everyone, and bye.